In this video, we're going to go in and we're going to insert a support ring for our central strut. Now, the support ring has already been designed, and you should have it as a 3D file that you can download. Hopefully, you have that in your files somewhere now. And what we're going to do is we're going to upload it and then bring it into our assembly. So to do this, we're going to open the data panel. We're going to go to Upload, and we're going to either select your file or you can drag and drop it, like I'm going to do, into here. You'll see the Hexpod strut support v1. Press Upload, make sure its location is the Hexpod project that we have, and you'll see it's start to upload. You'll also be able to see, if you go to Job Status here, and View Job Status, you'll be able to see this same page. So it's complete. You'll see it appears on the left hand side. It might take a minute to update just the image here, and if it's not updating in your data panel at all, you can always go and refresh your data panel at the top. We have it here. I'm not even going to open it in this case, but I am going to insert it into our design. So I'm going to right click, insert into current design. Fusion, we'll put it straight in. I'm just going to move it up out of the way so we can see what we're doing. Click OK, we can close the data panel. Orbiting around, you can see it's just a ring, and we're going to put it in between our two base plates to support them. First of all, you can see actually the origin is still showing in our part. Now, each component has its own origin, and normally they're turned off, but every single component has its own origin. What this means is that whenever you have all your origins turned on, you have a lot of yellow planes lying around and it can get in the way a little bit. So I'm actually going to go in and turn this off. Now, because this is a linked structure or a linked component, I have to use Edit in Place. That's fine, click on Edit in Place, and once that's happened, I can turn the origin on. Click on the tick, and you'll see it's gone. Now, what I'm actually going to do is turn off the link component. I've brought it in, which is great, but I don't need it to be linked to any other file. It's just a single part, and I'm quite happy for it to be in this component, in this assembly. So what I'm actually going to do is I'm going to right click on the component. You can see it has the little link icon here, and when you right click, there's an option to break link. If you click on this, you'll see that the component goes back being a normal component with no link icon, and this now means that whatever we do to this component in this file will not happen in the other file. You'll still see that our Hexpod strut support is still here in our data panel, but these two are now not linked, so anything we do to either of them won't make the difference to it on. The reason I've done this is just so that it's a little bit easier to work with. We don't have to keep going into Edit in Place, and we can work with them as an assembly. But more than anything, I just wanted to show you that you can do it. First thing we're going to do is we're going to apply a joint, put it into the correct place. So hopefully you know how to do this by now. Create a joint from the Assemble menu. I'm going to orbit around, and I'm going to hover over this area, hold Control, select the central part. I'm just going to do the same with our central base. It should slot into place quite nicely. In this case, it can be a rigid joint. You can see we now have our central support strut. It actually isn't fixed to anything at the moment. What we need is some holes in the bottom of our strut that we can put through into our base plate. To do this, first thing I'm actually going to do is I'm going to isolate it. What I want to see is only this base plate and our ring. Now, either I could go through and hide every single component, but there's actually a very easy way that you can do things. If you highlight parts, you can right click and isolate. And what this does is it hides every part other than those that have been selected. A really useful tool to be able to quickly just be able to see what you want to see. So I'm going to go ahead and look at it from the top. And what we want to do is we want to create a hole. I'm going to go in and use the hole tool and select our surface. Now I could, if I wanted to, go in and use a sketch point and reference it exactly. I'm not actually going to do that. I'm just going to do it by eye. Make sure it's roughly in the middle. I think that looks pretty good. And what I want is for this to be a M5 hole, or a 5mm hole. But not only do I want that, I want it to be tapped. There needs to be a thread inside of this, because I don't want to have to keep putting on all these nuts. So we're going to create this as a threaded hole. Now to do this, instead of using the simple hole tools that we've been using before, we're going to go in and we're going to use other types. To start with, we're going to create it as a countersink hole. Now what this does is there's countersink bolts, if you've seen them, that have angled heads, which means that the top of the bolt can sit flush with the top surface of our strut, of our support strut. Once we've selected the exact size that we want, this will automatically generate. Really useful tool. The next one, and probably the most important, is the hole tap type. We want this to be a tapped hole with a thread inside of it. So if we select tapped, you'll see that we can choose the hole and the thread that we'd like. I'm going to leave it as a full thread rather than an offset, so the entire hole has a thread. And you can see now down at the bottom here, we have a lot of options as to our thread and what we can do with it. As I said before, we want this to be an M5 hole, so I'm going to select 5mm, and then you can also select the pitch of your thread. Now I'm using the ISO metric system because that's what I use in the UK, but you can choose any of the thread types that you might want to use. You'll see that the hole diameter is automatically set for us because Fusion knows that size. And we now have our hole. You can also change your countersink size a little bit. I'm going to make mine a little bit bigger. That's pretty good. Just so that we can fit our screw in. Now that we have generated our hole, there's one important feature that you should be aware of. First of all, looking at our part, it's actually cutting through both our bottom plate and our top ring, which is exactly what we want. But you can see here, if I look from the bottom, you can sort of see the outline of the thread. But it looks a bit fake, and the reason for that is it is fake. This is actually a Fusion generated image, it's not the actual thread modelled itself. Now you might see at the bottom here there's a checkbox for modelled, and by clicking this, if I zoom in on our thing, you can see that it switches to actually modelling the thread physically. Now the reason that Fusion doesn't model it by default is that a lot of the time if you don't need it, for example, if you're going to manufacture it, you'll typically drill a hole first, so you need to know that hole size, and then you'll just take a tapping tool to it or a die, depending on the thread. So a lot of the time it doesn't model it because in this instance it's not very useful, and all it does is it adds in loads more faces and geometries and edges, and all that does is slow your computer down. So normally, if you don't need a physically modelled thread, I just leave this unchecked. It doesn't affect your part in any way, you still have the thread there. In an engineering drawing it will recognise that, but it means that it doesn't slow your computer down. When you have 100 of these holes all with threads, you just add a lot of faces for Fusion to compute through. The only time, or one of the few times that you might want to use the modelled feature, is if, for example, you are 3D printing your part. If you want that 3D printed part to have the thread in the 3D print rather than putting it afterwards, you need it to be modelled rather than just an image. So you need to check that modelled option there, and then the actual physical geometry will be exported when you take it to 3D print it, and then it will be created. Just something to be aware of. I'm going to leave it off for now. We have our hole going through, so I'm going to click OK. You can see we have our thread going all the way through and a nice countersink at the top. We only have one of them, and one of them isn't going to help us fix this plate down to the bottom all that much. So what we want to do is we want to replicate this around, and we're going to do the exact same process that we did all the way at the start with our outer holes, which is use the pattern tool, except this time we're going to be patterning the actual feature itself rather than the sketch. Now you can do this from the Create menu, go down to Pattern, and we have 3 options for pattern, and we want a circular pattern because it's going around a central axis. On the drop down you can select Features, and this allows you to go in and select the specific features that we've generated. Another way that you can do it, you can actually select the hole from the timeline. By doing this, you're selecting the entire feature that we just generated, and you're making sure that you have the thread and the hole and everything. We select our central axis. We can either select our axis line in the middle, or you can actually select this cylinder, which will choose the central axis of that cylinder. I want it to be full, and we're going to have 6 of these, just like we had 6 of our outer points. Click OK, and you can see that this feature has been patterned or replicated through with our countersinks and our threads all included. You might notice that your top base plate also has these threads. Now we haven't just cut a hole through those, but the top base plate has these because if you remember way back at the beginning when we copied this base plate, we pasted it as a normal paste rather than a paste new. What that means is that the top base plate and the bottom base plate are linked, so any changes that are made to the bottom are made to the top. So therefore, adding this hole, we've actually added them in the top. Now in this instance, it doesn't matter too much. I'm actually going to leave it, but you could fix this by going in and removing that top base plate. Then I actually joined all my joints are on the bottom one, removing that top base plate and replacing it with a paste new. I'm going to leave it for now. I'm quite happy with it. It's just something to be aware of. You've always got to be aware of those linked components, and a lot of the time I'll choose to just paste new because it makes life a little bit easier. I'm going to go back and reactivate everything. Now you can see that I unhid this, but to unisolate everything, you can right click on the hex pod assembly at the top and choose unisolate all, and this will unhide everything for you. So we have our holes in the middle, and then we have our support ring. The next thing that I want to add is a dome to the top. So normally we put electronics in the middle here. We're not going to do this in this, but you could easily download an S3D file of an Arduino or whatever electronics you want to use and just insert it. I'm not going to. I've shown you how to upload things, so there's not much point to it in this video. But you can. But to do that, we're going to house that electronics in a dome that goes over it and protects it. So to create this dome, I'm going to start by creating a new component, as we always do. I'm going to call it dome. Dome. You'll see it pop up at the bottom. I'm going to start by creating a new sketch on the side profile or the front profile. Now we're going to draw our dome in here, but to do this we want to reference this bottom part. If I try and draw any lines now, you'll see that nothing is constraining to what's already there. So what that means is that we need to project our parts. So we're going to go in, project, or I could press P. I'm going to choose the bodies option and project the entire of our top base plate. Once I've done that, we have these purple lines that come up, and I can now lock onto these lines. I'm going to start by drawing a straight line directly up from the center at the top of our base plate. You can see the midpoint constraint there has gone in, and I'm going to draw this 50 millimeters tall. Now what we're going to do is we're going to draw one side of our part, and then we're going to use what's called the revolve tool. Now what the revolve tool does is it takes a profile and it rotates it and generates a body as it rotates around an axis. So we need to generate one path, one profile, and then we'll revolve that around. So to do this, we're going to use what's called the spline tool. Now the fit point spline, or the spline tool, allows you to draw weird curvy shapes and control them, or lines I should say. So if you click on fit point spline within create, we're going to click on our end, and then we're going to click. Every time you click, it adds in a bend. So I'm going to click once here, and then once down at the bottom. Once you're done, click on your tick, and you'll see that this spline shape takes place. Now the great thing about the spline is that you can very easily control what each bend is doing using these green dots that appear. If you click on one of the dots at the end, you can move around the line, both in distance and in where it goes. And effectively this line is the tangent to your curve, and it allows you to really easily control what's going on. Now the first thing I'm going to do before I do anything like that is I'm going to make sure that this top part is as flat as possible. Because we're revolving this around, if I have it not flat, it's going to dip in or bulge out and have a point. We don't want that. We want it to be completely flat at the very top. So what I'm going to do is I'm going to use a constraint. I'm going to draw in a line by pressing L from this point out to the side. I'm going to make it a construction line. And then what you can do is you can fit these green points, much like any other sketch point, onto a line, and that will lock it off. Now that we've done this, because that line is there, this curve at this point is now tangential to the top, and therefore it's flat. So that's the first thing I want to do, because afterwards I could edit all this and it might change. So now that that is fixed, I can change all the other curves. Same goes for here. I actually want this to curve up slightly. Curve up slightly and have a slightly straighter edge. Now, Fusion has locked it in for me, and I can extend how long I want this to be to define how far up it goes. It's looking pretty good there. You can also click on the actual points themselves and move them around if you'd like to. So it's really up to you as to what you want to do with this. I'm going to create the shape a bit like this. But like I said, design what you'd like to. This is a bit like a dome, but we want to make it look cool for our renders and for our actual design. Move around your different parts until you're happy with them. And then once you are, you can click OK. I think that looks pretty good right there. Now the second part to this is now that we have our spline line, we actually want our dome to be hollow to allow our electronics to sit inside. So what we can do is, rather than revolving this whole area, we can cut down on the area we want, and we can use what's called the offset tool within Modify. The offset tool allows you to select an area, and it will offset that area according to the distance from the line. Now, with chain selection on, which is normally the default, it will select an entire chain. But in this case, I don't want that. I just want my single line. I'm going to turn chain selection off, cancel, come back in, make sure it's off, and just select this one line that I want to replicate. From here, I can drag it down, and we're going to have a wall thickness of 3 millimeters. In this case, it's -3 because it's going inside, and you can see that that line is now offset at the same ratio. Click OK, and you should have another area that's arrived. Now, depending on your shape, you might find that it's not quite meeting the bottom line, and therefore it's not an enclosed area. If that is the case, you have a couple of options. Either you can try and redraw your spline, but a much easier option is to go into the Modify menu and choose Extend. Now the Extend tool continues a line up to the point that it meets another one. So much like the Trim tool, cut between two lines. If you select an end of a line, it will continue that line at the same direction until it meets another line. So here, for example, I could extend this down to the bottom where it meets the next sketch line. I don't need to because mine's meeting. But if yours is just a millimeter away from the side edge, you can use the Extend tool, select it, and it will extend it up to that line. I don't need to do that, but it's a useful tool to know about. It's very useful to be able to go through it. So we now have our area, and this is what we're going to revolve around. I'm going to finish the sketch. You can see this profile, and then what I'm going to do is I'm going to create a revolve. Now this comes up with a profile, an axis, and a type. So by profile is that area we just created. The axis is the axis of rotation. We want it to rotate around the center, which is the line that we sketched here. And you'll see that once I've clicked that, it creates this full revolve around our part. Now you don't necessarily have to use a full revolve. You can have a 180-degree revolve, for example, and it would only revolve half of it. But you can see also that it's hollow. I'm going to leave it at full, click OK, and you can see that that top part has been generated. Now, we just saw that it was hollow, but another way you could do that is using the sectional analysis tool. We used this earlier, so actually we already have an analysis. So we could cut it in half, and you can see how this is worked. We have our hollow part at the bottom, we have our hollow part at the top. So we have our hollow area, and if you didn't remember, to get the section analysis, you go Inspect, Section Analysis, and then you select a plane that you wanted to cut through. Now there are also a number of other analysis or inspect tools that you can use here. One that I'm going to look at, I'm going to turn off my analysis. I'm going to use the zebra analysis. Now this allows you to detect curves and how smooth a curve is. If I select that, I select my top body, for example, you can see that it applies this zebra pattern to it. And as you move around, you can see how smooth everything is. Now if I had not done that tangential point at the top, this top point wouldn't be anywhere near as smooth, and there would have been a little dimple and a little point. You could have seen that in this. The idea of a zebra analysis is that you can select multiple parts to do a zebra analysis on. And on these parts, whenever the black lines or the white lines don't line up with each other, that means that there's an area that isn't smooth. So you can see here that between our bottom plate and our top plate, there's a big black part here, and it does not correspond with the black parts on the next part, which shows that it's not a smooth part between them, which makes sense because they're separate bodies and they are sitting on top of each other with a sharp edge. But it's a very useful tool to be able to see exactly how your curvature is going and how smooth it is. There are some other ones here. You can choose the center of mass. You could find the center of mass of your whole part. There are some other ones as well. Draft analysis. And we're going to go through interference in a little bit. In the next video, we're going to go into the sculpt environment, and we're going to add a few things to our part on the top using a completely different environment and using a slightly different way of modeling.